matched or is not matched. Now this would be difficult, but we know a device that should help us. If we put there a transformer, remember that if a transformer has a ratio of windings n, it transforms the impedances with n square. So if there would be a transformer, an ideal transformer, and the ratio of number of turns would be a square root of 2. So for example, we would have 100 turns here and 142 turns here, more or less. It would transform the impedance so that this impedance transformed through the transformer would behave like a 1 ohm here. So from this side you would see a 1 ohm feeding line, 1 ohm load. Good. If you switch over the transformer and watch it from here, you would see that this line has been transformed into 2 ohms, and you have loaded it by 2 ohms. So the transformer would transform the impedance of the other part of the circuit so that really there everywhere is kept the condition of impedance matching. Now, please note that although the transformer is capable of providing impedance matching, the way you connect it into the circuit matters. If you just change the windings, you would have a transformer that would transform a 1 ohm into half ohm on this side. So if you have a circuit that could provide for matching and you just turn it, then you get worse matching than without the circuit. It is important in which direction you connect that circuit. So this is the first remark. Well, unfortunately, we would have a problem with a transformer, let's say, at 5 gigahertz. That's something you could not build. Or if you build it, it would work very, very badly. The other point is that we do not only match real impedances, but also complex. And for that, a transformer would mostly not work. So now let us examine the way with which we can create something which we call a matching circuit that somehow converts those two impedances so that they become complex conjugate. We start with the most common point, and that is we will match to, in our case, a 1 ohm source, anything that should be matched. Now, are there any circuits that could be matched to a 1 ohm source? So the resulting circuit is this point. Are there any circuits that could be matched to 1 ohm by connecting an inductor in series? Remember the start of our talk with Smith chart. If you have any circuit that has a real part of the impedance of 1 ohm, so any circuit that is on this line and is capacitive, for example, this point, this is, if I just check the, well, that's something like 1 real ohm plus minus 3J ohms capacitive. So this could be matched just by connecting an inductor. If I provide here an inductor, it will cancel the capacitive impedance and get the circuit here. So any of those circuits on this half circle could be converted into a matched circuit just by adding an inductor in series. Which value of inductor? Well, I can read the imaginary part. There is the reactance X, and that should be J omega L. If I connect in series an inductor at this frequency, it would have the reactance of X, which would be the same like this one, just opposite sign. And those would cancel, and I will result in 1 ohm, which is the match to a feeding line of 1 ohm. I can do the same with a capacitor. Just in this case, I would cover this half of the unity circle. So now I know that anything downstairs I can match, anything downstairs on the circle, I can match with an inductor in series. Anything upstairs I can match with a capacitor in series. So we are quite happy. At the moment we know how to match an infinite number of impedances. Anything that lies on the unity circle could be brought to impedance matched condition by connecting in series a capacitor or an inductor, which is very nice. Unfortunately, still there is a lot of impedances that cannot be matched by this way. Then there is a mathematical way of solution. Do you know, if a mathematician has to fill a glass with water, so he takes the empty glass and fills it with water. And what about filling a half empty glass? Well, first he throws the water away and then he uses the first recipe, fills the water. So, the important point, we have to get some way how to convert other cases to the case we have already solved. And now I will show you the way of matching, for example, our 2 ohm resistor to a 1 ohm transmission line. So we find something that would convert the case of a 2 ohm resistor, this is the position, to this or this case. So we have to move this point to the unity circle, upstairs or downstairs. How to do that? Well, okay. Just remember, well, if we connect anything in series, we would not get there, only at infinity, which is not useful. But through any point within the Smith chart, there is at least one circle of constant real part of impedance and one circle of constant real part of admittance. Remember, if I connect there in parallel an inductor, what would happen? Well, if I have a real impedance of 2 ohms and I connect an imaginary impedance in parallel, I would not change the real part of the admittance, so it would still be on this circle, but I would change the location. So if I add an inductor, and the inductive reactance could be found on this kind of line over here. So if I add the inductor, I move this point, I transform it to this impedance. And bingo, I know how to change it into this position. So if I have a 2 ohm, load, I first connect in parallel an inductor which changes the value from here to here, and then I connect in series a capacitor which would resonate out the real part of the impedance, and I will result with something which behaves like a 1 ohm resistor. Of course, this only holds at the design frequency. At that frequency, I would get the proper value of the inductance, inductive susceptance, and capacitive reactance. But I have constructed something which acts like the transformer. It consists of two elements, an inductor and a capacitor. And those two elements, at least by its nature, are lossless. So I have not lost power. I have designed something that converts this 2 ohms into 1 ohm from this side. But if you look at it from the other side, the 1 ohm is converted into 2 ohms by this transforming element. Again, it matters whether you connect it this way or whether you first connect the capacitor and then the inductor. Then it would not work. So this is a way how to design a matching circuit. Now, looking at the circuit, you might be a bit surprised because you must have seen it already. This is a high-pass filter. At low frequencies, it does not permit. First, the inductor makes a short circuit, a capacitor makes an open circuit, so this is not connected at low frequencies. At high frequencies, it's fully connected because the inductor is switched off and the capacitor is short-circuited. This is true. In fact, the most known book on filters, microwave filters, is called Microwave Filters and Matching Circuits, because the task is the same, filtering. In fact, an analog technology means that you create a matching circuit that matches well the load to the source within the passband so that there is perfect transmission of energy. And out of the passband, the matching is bad, therefore the energy reflects back and does not get to the load. Impedance matching and frequency filtering is the same problem, just seen from other points. Mostly with frequency filters, we need high selectivity, that is a very narrow passband. With matching circuits, on the contrary, we mostly require as big passband as possible. So, in frequency filtering, we aim to high quality of the circuit. Remember to that Q as a ratio between a passband and center frequency. And in matching circuits, we aim at low quality of the resonant circuit involved, mainly. Now, I wanted to give you this as an example. What I will do now, or today, I will not only post my lecture on the YouTube, but I will add a sketch of this matching problem into a Smith chart. Please do the same job by yourself and then check against my drawing, because that would ensure that you understand the work with Smith chart. Now I wanted to show you the basics of impedance matching only using lumped elements. There are also other techniques using stubs and line sections which are more suitable for higher frequencies. And after all, as there are numerous filters, there are numerous matching circuits. That's the same coin, just other sides. So this is what I wanted to show you about impedance matching. And I will make a short break. After that break, you are expected to ask questions, and if not, I will switch to the last things, that is, I will talk on examination. So a 5-minute break. Well, hello again. Your questions. If there are no questions, we are gradually moving to the last part of the lecture, which in this time would be about the examination. So first I will briefly repeat the conditions, especially with respect to this year, because we will run mostly or possibly entirely in distant mode. And then I will be happy to reply your questions. So first, we have an examination that consists of two parts, written and oral. Now the written part consists of two parts, a set of 10 questions out of the set of 42 that are already on the internet, and then 3 simple tasks. The whole time for the examination is 1 3/4 of an hour, and in the situation we are doing that on internet, it is exactly 2 hours, because I add you 1/4 of an hour to make a copy, a snapshot, a scan of your written part, and to send it to myself back. So the golden rule is that 2 hours from the beginning of the examination, I should have your written results in my email box. Now, each theoretical question is for 1 point and could be awarded with 0, 0.5, or 1 point when I grade it. And then each of the tasks can achieve as much as 10 points. Depending on the number of points you get from the written part, you get a mark, and I put that mark into COS, mostly in 3 hours from the end of the written part. The hour would be communicated for each examination separately, but it will be written somewhere. Now you finish the written part, you submit it through email, I will print it, mark it, and put you the mark into COS. Now you have 1 working day to decide whether you accept the result, which is in COS, and then you do nothing and you simply have been graded, or whether you want to get better mark. If you want to get a better mark, you will proceed in one of 2 possible directions. The first is that I will make a doodle with possible times and you will choose one. It's assigned on first come, first served basis. So if you do that earlier, you can get better choice of times. If there is no time that suits you, you drop me an email, and you have to do this by the midnight of the day after the work day, after the labor day, after the results have been put into COS. So typically we have an examination on Friday, let's say from 9 to 11. At 2 o'clock in the afternoon, there are the results in the COS. And by midnight on Friday, on Monday, on next Monday, up to midnight, you can drop me an email requesting an oral exam, or you can select one of the times in the doodle. And then we proceed with oral exam, and the golden rule is that I will check what was causing you most troubles in the written part, and I will assign you other questions or tasks from that part of electromagnetism. So I will not touch what you have already known, but I will make sure that you now know what you have not known in the written part at the time the written part has been concluded. And of course, you might gain or not. Due to COVID, we have an additional rule. Normally you could also worsen your mark in the oral exam, but this time you cannot worsen it. Just if you do not succeed with the first task, the mark remains. Now, as to the organization, it is absolutely necessary that you have a camera and your microphone on during the written part so that I can see and hear what happens in the room, and the camera should point to you. So that's the golden rule. If you have no camera, that's a problem and you have to get one for the examination. Now, I'd possibly like to get your questions as to the organization of the exam in COVID times. Please. Since there are no questions, then we can just make a few marks. First, of course, it would be very nice if you have 40 points from the written part, but that's a kind of miracle. For example, if you make a numerical mistake, that is, you use good equations, but you input wrong numbers, or you mistype your calculator or something like that, then a numerical problem is 1 point less. But then I have to get this wrong result and continue the equations with this wrong result to check whether you have made more mistakes. And if this is the only mistake, which makes all the results numerically incorrect, but there is only one mistake, that's only 1 point less, you would make my mission much easier if you include the equations. If you just write down a result which is wrong without any clue of how you got it, then it's no points. So I am trying to find anything that is correct and mark it. Yeah, I have a question in chat. Which topics will be in the test and what type of questions? Well, first, there are questions. There are 42 questions you can find in the Moodle that have been there explained at the beginning of the term. And those are the questions that I will ask in the theoretical part. In fact, there are only 41 because I have skipped Green's functions and I will not, therefore, use that for examination. So Green's functions are out of scope. You have only 41 questions for the written part, of which I will select 10 for each run of the examination. And second, as to the tasks, you had some tasks during your seminars, which are good tasks to be performed at the examination. And I have performed something at the lectures. Again, good topics for examination. So that's it. Most commonly, those will be simple tasks that would reveal whether you only remember the definition or the formula, or whether you understand what the letters in the formula mean. This is quite easily checked by a simple task like find out the inductance of an inductor, or calculate the capacity of a plain capacitor, find out the breakdown voltage of a capacitor, and so on. So yes and no. I will start, once you subscribe for an examination, I will create a special Microsoft Teams group for that examination. And at the beginning of that examination, you will find there a file describing the rules, like you send it to that and that email by that and that time, the results will be encoded by that and that time, and so on. And you will also see that just at the beginning, a PDF of the assignment. So you have to be present in Microsoft Teams, which is the environment we will make the examination in. Are there any more questions? So now there is another rule for consultations. I will run a consultation, and this will be sent to all of you, even to those who have already passed the exam. So I will invite for a consultation in Microsoft Teams generally 2 days before the exam. So the next exam is on 15th of January. I will make a consultation on Wednesday, 13th. In my opinion, 2 days ahead the examination is a good distance because you already have read something, so you know what to ask. And still there is some time to improve your knowledge if you find that during the consultation. I'm not telling that I will not consult at other times, just you should drop me an email in advance and I will do my best. I'm not available all the time, but I like consulting, so I will do my best to provide a consultation. Are there any more questions? Well, second question, are there any more questions? Yes, 20 points are enough for passing. That's the rule of Czech Technical University. The E mark is 50% of knowledge. That's it. Well, if you get 18 to 19, you will have to undergo an oral part of the exam and hopefully win. You have the right to go on with an oral part also if you get 5 points. But then you have to improve a lot because we have to get to the ratio 50% of known to all, or 50-50 known to unknown. So I can give you a simple task. I have a set of simple tasks for those who have reached 18, 19 or 17 points, who are slightly below the level. And I have a set of less simple tasks for those who reach 5 or 10 points. Oral exam is optional, so the rule is I will give you some mark into COS, and if you agree, you do nothing, you do not show at the oral exam, and you get the mark. Well, okay. Are there any more questions? Any more questions for second time? Well, the last possibility to ask. Okay, so now we have had a strange kind of education during COVID times. I'm sorry I have not seen you except for a screen during consultations, which which is not very nice. So still, I repeat, you are my students, and if later you find that you need to know something which was in this course but was difficult to acquire due to the situation, you are still welcome to come to a consultation and ask, and it would be a pleasure to meet you. Now I hope that we will reach some times where we'll be able to meet person to person. I'm looking forward to that time. I hope all of us will survive towards that time, and I have just best wishes for you for the examination and for your entire study and for your entire life. It's been a pleasure to meet you. See you.
Thank you.